Neuroplasticity is the brain's ability to rewire itself based on our behaviors, experiences, and environment. For years, scientists believed that the brain was fixed after a certain age. That belief has been completely overturned. The brain is plastic, meaning it is changeable, and it responds especially well to consistent, repeated action. When you commit to a habit and repeat it daily, you are quite literally carving new neural pathways that make that behavior more automatic and less effortful over time. When we talk about small habits, we're talking about actions that are so simple they almost feel insignificant. Making your bed, journaling for 2 minutes, getting sunlight in your eyes after waking, drinking a glass of water right away, taking a short cold shower, writing your goals down at night. These behaviors don't rely on willpower once the neural circuits have been trained. And that training happens through the mechanism of neuroplasticity, but only under specific conditions. There's a neurobiological reason why 21 days is a powerful benchmark for behavioral change. The first 7 to 10 days of habit formation activate the brain's alertness and resistance systems, primarily the anterior mid-cingulate cortex and the locus ceruleus. These areas signal discomfort when you're doing something unfamiliar. That discomfort is not a sign of failure. It's the brain literally resisting the reorganization of existing patterns. But if you push through this resistance by repeating the behavior, you activate neuromodulators like acetylcholine and dopamine, which begin to enhance the signal strength of that habit loop. From days 10 to 21, the repetition creates a deeper imprint. You engage the basal ganglia, specifically the dorsolateral striatum, which is the area responsible for storing automatic routines. Think of this part of your brain like a high-efficiency automation system. Once this system identifies a pattern that is repeated consistently, it starts to store that behavior and makes it easier to perform without thinking. This is why, after around 3 weeks, something that felt difficult or awkward, like stretching for 5 minutes every morning, begins to feel normal, even necessary. Neuroplasticity is not just about doing something over and over. It's about doing it with attention and consistency. When your brain senses that a behavior is being repeated predictably and with some emotional relevance, such as the satisfaction you feel after doing it, it flags that behavior as worth keeping. The neurons involved in that pattern begin to fire more efficiently, more quickly, and with less cognitive effort. You're essentially lowering the activation threshold in your brain's circuitry for that habit. The most effective small habits are the ones that target your state early in the day. This is because your brain is most plastic, most capable of change in the early hours after waking. Cortisol levels are naturally elevated during this time, which helps encode new information and behavior. When you repeat a small habit in that state, you are more likely to strengthen its neural pathway. This is also why morning routines tend to have a disproportionate impact on long-term behavior change. You don't need motivation to rewire your brain. You need repetition. And that repetition, when structured correctly, taps into the brain's natural architecture for learning and efficiency. The truth is, every small decision is training your nervous system. Every time you repeat a small habit, even when it feels inconvenient, you are teaching your brain that this action matters. And in response, your brain starts to adapt. It begins to prune away the old connections that no longer serve you and build new ones that reflect who you're becoming. Dopamine is often misunderstood. It's commonly labeled as the pleasure molecule, but that definition is far too narrow. Dopamine is less about pleasure and more about motivation, drive, and anticipation. It's the molecule that says, move toward that, pursue this, stay in the game. When you set out to change your life using small habits, your ability to harness dopamine becomes the difference between staying consistent and burning out after a few days. The critical insight is this: you can train your brain to release dopamine, not from the reward itself, but from the pursuit of the habit. Every time you complete a small habit, even something as quick as writing down your intention for the day or taking a cold shower, there is a small but measurable dopamine release, assuming the behavior is attached to a goal or a sense of progress. What matters is that the brain learns to associate dopamine with effort, not just outcome. This subtle but powerful shift trains your reward system to be engaged by the process. And once that happens, motivation becomes self-sustaining. Dopamine operates on a system of baseline levels and spikes. Your baseline dopamine level determines your general motivation, mood, and ability to focus. When you do something rewarding, dopamine spikes above baseline. But after the spike, there's always a dip. That dip is important to understand. If your entire focus is on chasing external rewards, likes, attention, success, validation, you become dependent on the spike. And because every spike is followed by a crash, you start needing bigger and bigger rewards to feel the same level of drive. This is where dopamine becomes a trap. It pulls you into a loop of chasing novelty and stimulation instead of sustainable growth. But there's another path. You can train the brain to get dopamine from small, effortful actions. This isn't just a mindset, it's neurochemical conditioning. When you celebrate small wins like completing your morning run, drinking a glass of water before coffee, turning off your phone for 10 minutes of deep work, your brain registers the behavior as successful. The dopamine system learns that showing up equals reward. And once your brain internalizes that effort equals reward, you begin to reinforce the circuitry for discipline and consistency. This process engages the mesolimbic pathway, particularly the nucleus accumbens, which integrates motivation and motor action. It's the system that moves you toward a goal. Here's where it gets strategic. You can enhance this process by pairing small habits with internal reward signals. It's not about forcing fake positivity. It's about deliberately acknowledging your effort, saying to yourself, that was hard and I did it anyway. That simple internal dialogue stimulates dopamine release from the ventral tegmental area, increasing your motivation to repeat the behavior. Over time, the brain starts to prefer the pursuit over the prize. That's where true habit mastery begins. Another crucial factor is novelty. The dopamine system is responsive to change. If your routine becomes too monotonous, the brain habituates and the dopamine response diminishes. So you must find subtle ways to refresh your habits, changing location, adding variation, or simply tracking your progress in a new way. These small adjustments can maintain the novelty signal that keeps dopamine responsive. This is especially important around day 10 to day 14 of habit formation, where most people hit a motivational dip. That dip is not failure, it's biology. It's the dopamine system recalibrating. When you understand this, you stop interpreting dips as setbacks. You start seeing them as part of the process of reconditioning your nervous system. Sleep, nutrition, and sunlight also influence baseline dopamine levels. If you're not sleeping well, if you're skipping protein, or if you're staying inside all day, your dopamine system won't function optimally no matter how much willpower you apply. So supporting the system biologically is just as important as using it behaviorally. Think of your dopamine system like a battery. Habits charge it, awareness protects it, and intention guides it toward the outcomes you actually care about. There is a biological clock inside your brain, and it controls far more than just your sleep. This master timekeeper, located in the suprachiasmatic nucleus, SCN, of the hypothalamus, governs your energy, mood, metabolism, cognitive performance, and even the timing of hormone release throughout the day. What this means is that your entire system, from your attention span to your willpower, is operating on a cycle. And the most powerful way to influence this cycle is through what you do in the first 60 to 90 minutes after waking. Your circadian rhythm is not just an abstract concept. It's a real physical system of gene expression and hormone modulation that is responsive to behavior, especially light exposure and body movement. When you develop consistent small habits in the morning, habits that cue your brain that it's time to be alert and active, you are literally anchoring the rhythm that the rest of your day depends on. These habits act like timestamps for your internal biology. And the timing of the habit matters as much as the habit itself. One of the most powerful triggers for setting the circadian rhythm is sunlight, exposing your eyes to natural light, not through a window, but directly from outside. Within 30 to 60 minutes of waking triggers a cascade of neurochemical events. The light stimulates melanopsin containment retinal ganglion cells, which send signals to the SCN. This starts the clock on your cortisol rhythm, body temperature rhythm, and melatonin suppression. It creates a clear contrast in your system. Day has begun. Alertness is required, and it's time to shift into forward drive. That cortisol spike in the morning is not the stress hormone we often think of it as. It's a healthy, necessary pulse that sets up the body for optimal energy distribution, immune readiness, and focus. However, if that light exposure doesn't happen, if you stay indoors with low artificial light, that cortisol spike becomes delayed and blunted. This results in grogginess, poor focus, and even mood instability later in the day. What's more, your melatonin rhythm, the signal that helps you fall asleep, also becomes delayed. This is why staying inside in the morning can lead to both low energy during the day and difficulty falling asleep at night. Movement also plays a key role. When you engage in even 2 to 5 minutes of light physical activity early in the day, whether it's stretching, walking, or breath work, you increase core body temperature and stimulate norepinephrine release from the brainstem. This creates a heightened state of alertness without anxiety. These simple signals tell the brain and body that it's safe and appropriate to be active, creative, and productive. That's when motivation begins to self-generate, and when the systems responsible for focus, particularly the prefrontal cortex and the acetylcholine system, begin to activate more efficiently. Temperature and nutrition habits also interact with the circadian system. Drinking water before caffeine rehydrates the brain and reduces sleep inertia. Waiting 90 minutes after waking to consume caffeine prevents a midday crash by allowing adenosine, the fatigue molecule, to naturally clear from your system first. These are small habits, but they synchronize your internal systems for better overall performance. They optimize your energy window, especially between 9 a.m. and 1 p.m., when most people have their greatest potential for deep work and learning. Another key factor in morning routines is intentional stillness. Starting the day with 1 to 3 minutes of focused breath work or even simple silence activates the parasympathetic nervous system and trains the brain to balance arousal with control. This improves executive function and emotional regulation throughout the day. The dorsolateral prefrontal cortex, the area responsible for working memory, planning, and impulse control, becomes more stable when it has a calm entry point into the day. Over time, when you apply these morning routines with consistency, your internal systems begin to anticipate them. Your brain and body start preparing for wakefulness before the alarm goes off. That means your cortisol rhythm sharpens, your melatonin rhythm resets, and your metabolism begins shifting earlier in the day. This anticipatory regulation is called entrainment, and it is a core principle of circadian biology. Once your system becomes entrained, it starts working for you instead of against you. Focus becomes easier, energy becomes more predictable, and your mood becomes more stable. And all of that starts not with a huge transformation, but with small, repeatable signals that you send to your biology every single morning without fail. The brain doesn't operate in isolation. It thrives on association. This principle that neurons that fire together wire together is one of the foundational truths of neuroplasticity. When you engage in behaviors in a specific sequence, especially repeatedly and in the same context, your brain begins to link those actions together into what's called a habit loop. This is where habit stacking becomes one of the most neurologically effective tools for behavior change. It uses the brain's natural tendency to build associations in order to make new habits easier to remember, easier to perform, and more likely to stick. Habit stacking means linking a new habit to a behavior that is already deeply ingrained in your nervous system. These existing behaviors are often so automatic that they don't require conscious effort. Brushing your teeth, putting on your shoes, starting the coffee machine, checking your phone, flipping on a light. When you piggyback a new behavior onto one of these anchors, the brain interprets the whole sequence as a single event. The cue for the old habit becomes the cue for the new one. Over time, that new behavior gets encoded into the same neural circuit, primarily in the basal ganglia that stores automated routines. The basal ganglia are central to habit formation. Specifically, the dorsolateral striatum encodes behaviors that require little conscious thought. But to get a new behavior into that system, you have to give it repetition, context, and some form of reward. Habit stacking does all three. Repetition comes from daily practice, context comes from anchoring the new habit to something familiar, and reward doesn't have to be external. It can be as simple as the emotional satisfaction of doing what you said you would do, or the shift in mood you feel after completing the action. For example, let's say you want to build a gratitude practice. Trying to create an entirely new routine might work, but it also requires more decision-making and willpower. Now, take that same gratitude practice and attach it to brushing your teeth at night. Every time you put down your toothbrush, you immediately say out loud or write down one thing you're grateful for. At first, it feels mechanical, but within 10 to 14 days, your brain starts to predict the next action in the sequence. You'll find yourself thinking about gratitude even before brushing your teeth. That's neural encoding in action. You've installed the behavior into your autopilot system. This also applies to movement, breath work, hydration, journaling, and visualization. If you drink a glass of water right after turning off your alarm and then immediately do 1 minute of deep breathing, that entire routine becomes one reinforced habit loop. The brain doesn't need to process each step individually. It treats the whole process as a unit. This reduces friction, conserves mental energy, and makes consistency more likely, not because of motivation, but because of structure. Habit stacking also activates the anterior cingulate cortex and the insula, which play a major role in attention and interoception, the sense of your internal state. When you attach emotional awareness or mindfulness to a physical action, the brain links thought and sensation, which strengthens the memory trace of that experience. This means your habits don't just become more automatic, they also become more meaningful. The emotional salience of the action increases, and as a result, your likelihood of repeating it increases too. The one overlooked aspect of habit stacking is timing. The brain loves temporal predictability. When behaviors happen at the same time of day, in the same context, they become easier to automate. This is known as temporal scaffolding. You create a mental map of your day based on repeated behavior sequences. And when those sequences are intentional, the entire day begins to shift toward greater order, clarity, and control. You're not just changing your habits, you're building a neurological framework that makes better decisions easier and more reflexive. One of the most underestimated forces in behavior change is self-perception, the internal narrative that defines who you think you are. Every time you act, your brain records not just what you did, but who you were being when you did it. Over time, repeated actions become tied to your identity. This feedback loop is not just psychological, it's deeply neurobiological. The brain is constantly updating its model of self through a network of circuits, particularly those involving the medial prefrontal cortex, the posterior cingulate cortex, and the default mode network, which is active during self-referential thought. When you adopt even the smallest habit, the real transformation doesn't happen at the level of behavior, it happens at the level of belief. Here's the critical insight. Every small action is a vote for the type of person you believe you are becoming. When you wake up early to journal, even if it's just 2 sentences, your brain isn't only logging that action as a task completed, it's also reinforcing the belief that I'm someone who reflects and writes. When you stretch for 5 minutes every morning, even when you don't feel like it, your brain doesn't just log mobility work, it strengthens the identity that I am a disciplined person. This repetition shifts your self-image from a vague intention into a neurologically encoded truth. Identity-based habits tap into the brain's prediction system. Your brain is constantly forecasting how you will behave based on past behavior. When you act in alignment with your desired identity, especially when no one is watching, the dopaminergic system flags that behavior as highly relevant. Dopamine is not just about reward, it's about signaling importance. When you repeatedly behave like the person you aspire to be, the brain begins to predict and then expect that behavior, which increases your likelihood of doing it again. This is how confidence is built on a neural level, not through affirmations, but through consistency. The anterior insula and anterior cingulate cortex, both involved in decision-making and self-awareness, begin to rewire their responses to internal signals when identity is involved. For example, if you identify as someone who never misses a morning routine, skipping it doesn't just feel like breaking a habit, it creates internal cognitive dissonance. That discomfort arises because the brain detects a mismatch between behavior and identity. When your identity is clear and repeatedly reinforced, you are far less likely to abandon habits, not out of guilt, but out of alignment. What makes identity-based habits especially powerful is that they are resilient to external pressure. Willpower fluctuates, motivation spikes and crashes, but identity, once internalized, creates behavioral momentum. That's because identity becomes a filter for decision-making. When faced with a choice, hit snooze or get up, scroll or journal, fast food or whole food, Your brain checks for consistency with who you believe you are. This mechanism is largely unconscious but highly effective. The ventromedial prefrontal cortex, which weighs subjective value and personal relevance, starts favoring decisions that align with your perceived self. It becomes easier to say no to things that conflict with your values and easier to say yes to things that reinforce them. One effective strategy for anchoring identity is using identity statements tied to action. Instead of saying, I want to exercise, you say, I don't miss workouts. Instead of, I'll try to read, you say, I'm someone who finishes books. The shift from aspiring to embodying activates different neural patterns. The former is processed as possibility, the latter as prediction. And the brain loves prediction. It's built to confirm what it expects. This means that if you start to expect yourself to follow through, your behavior will begin to conform to that expectation. Another key element is evidence accumulation. Every time you show up, even in a small way, you provide your brain with more data to support your identity. And the stronger that evidence becomes, the more entrenched the identity is. This creates a self-reinforcing feedback loop. Identity shapes action, and action shapes identity. With enough repetition, your nervous system doesn't just recognize the behavior, it starts to expect it as part of your baseline. You don't have to convince yourself anymore. You just act in alignment with who you already believe yourself to be. And the brain ensures the rest through systems of attention, emotion regulation, and habit automation driven by the prefrontal and limbic systems working in tandem.